Hello friends, today's question. A block B is attached to two unstretched spring S1 and S2 with spring constant K and 4K respectively. The other ends are attached to two supports M1 and M2 not attached to the walls. The springs and supports have negligible mass. There is no friction anywhere. The block B is displaced toward the wall 1 by a small distance x and released. The block returns and moves a maximum distance y towards wall 2. Displacements of x and y are measured with respect to the equilibrium position of the block B, the ratio of y upon x. So this is block B attached to two springs S1 and S2, and these springs are attached with M1 and M2, and these supports have negligible mass. So in the first case, block B is displaced towards wall 1 by a small distance x, and then it is released, and then this block B moves towards the wall 2 by a maximum distance of y. So let us draw the diagram for that particular condition. So this is the mean position. Now B is from the mean position y towards wall 2. So this is wall 2 and this is wall 1. So in this case, B is at a distance of y from the mean position. This will be our M2 spring, and this will be S1, and we are going to have this will be our M1. So this is spring S1 and this is spring S2. So this is the, so we have to find out the ratio of y to x. In this case, let us call this as figure 1, and this as figure 2. Now in the figure 1, this mass B, block B, is moved towards right. So because of that, the spring S1 will be compressed, whereas there will be no change in the, you can say, stretch. There will be no stretching in the S2 because M2 is massless. Okay. You can say from figure 1, spring S1 is compressed and no change in S2. Because M2 is free to move and is massless. So it means the total energy in the system, this entire system, will be only because of spring S1. You can say from here, therefore total energy in the system will be because of spring S1, and let us call that U1. So therefore we can write that U1 is equal to half K1 x square, where we assumed that K1 is a spring constant of S1. Later on we can substitute its value. Now it says that as the block is released, say after block B is released, it overshoots the mean position and moves toward, you can say, wall 2, and this is for figure 2. Moves towards wall 2. And the displacement from mean position is y. Now in this case, spring S2 will be compressed. Spring S2 is compressed and no change in S1. So therefore the total energy of the system let us call that U2, will be because of only S2. So therefore we can say about U2 is equal to half K2 y square. Now we can use conservation of energy by law of conservation of energy. You can say that U1 is equal to U2. We substitute the value, half K1 x square is equal to half K2 y square. Half and half cancels out. From here we get y square upon x square is equal to K1 upon K2. Now K1 is spring constant of S1, which is given as K, and K2 is the spring constant of S2, which is given as 4 times K. We substitute the values, we get y square upon x square is equal to K upon 4K. K and K cancels out. From here we can say that y upon x is equal to 1 upon 2. So this is the final answer, or we can say option C is the correct one. Option C is correct. We have option C as 1 by 2, which is the correct option. So this completes the question. Thank you.